Hello everybody and welcome back to the Stedmans YouTube channel. Today we've got this Range Rover Evoque, which has got an issue with the gear selector not rising up out of the center console. So what we're going to do today is we're going to go through a step-by-step diagnosis of the unit, so that if you're experiencing any of these troubles at home, you'll know exactly what to check and hopefully save you some time and money. So let's get into it and we'll see if we can figure out what's wrong with this car. Okay, so now it's time to confirm the customer complaint. So I've just got in the vehicle and I've got the engine running. We started, and however, the gear selector hasn't risen out of the center console. Now what I can do is I can still put my foot on the brake and scroll through the gears. Sometimes they're a bit stiff to engage. So what we're going to do next is we're going to have a look at some fault codes, see if there's any TPIs related to this issue, and then what we'll end up doing is taking up the center console, testing the wiring, and checking out the actual unit itself to see if we can find any defects with it. So we'll get onto that next. So it's going to be worth mentioning today that when we're using our software to read the fault codes out of the vehicle today, we will be using the Bosch KTS 560. Now what I'm going to do is I'm going to throw a photo up on the screen, and this is going to show what fault codes we had stored in the vehicle, and specifically we're going to be looking at the gear selector module. We have multiple fault codes here, which is P176 alpha, which is upshift, downshift, switch selector lever current outside of its max range, and P176 bravo, upshift, downshift, switch selector lever component sticking. We also here have a U0001 high-speed CAN bus signal invalid. Now we're going to be paying attention to those fault codes very closely as well, but it's also worth mentioning that we do seem to be having lots of high-speed CAN bus issues in other control modules. So next what we're going to do is we're going to go into the vehicle and we are going to remove the center console. We're going to check the wiring there, and if that's all okay, we'll remove the gear selector unit itself and we'll inspect that to see if we can find any defects with the unit. Okay, so now that we've read the fault codes out of this and we have confirmed the customer complaint, what we're going to do is I'm just going to take you inside the vehicle and we're going to go through a step-by-step process of how we're actually going to remove that center console panel and get to the wiring to test the gear selector unit and the module. Now, if we come into the driver's side of the vehicle and we look in through this storage gap that they give you in the back, what you'll see right up in here, if I just get my torch over there, is a Torx 20 screw bits. You're going to have one this side, and if you were to go through the passenger side, you'll also have a screw over there. So what we need to do is first is we need to unscrew both of those. So I'll do that now. Okay, so now we have the two screws down the back of the unit around here loosened off. What we can do is we can lift up the glove box and we'll pull back the panel. Now what we'll need to do is just grab the back of the unit firmly and lift. Once the back of the unit has been unclipped, you should feel that the rest of the unit will want to come with it as well. Now underneath there are going to be electrical connectors in here and on the other side as well. So what I'm going to do is I'm just going to move you over and I'm going to show you how to safely disconnect them so that no wires are being pulled. Now I've brought you back into the passenger side of the vehicle, where when we lift up on the control panel we can see our connector on the side. Now what we're going to do is we're just going to push in the tab at the top, and if we get our finger in there and lift up, as you can see, it's come away and disconnected. Now what we're going to do is we're just going to repeat the process on the driver's side as well. Now, with the panel lifted further up, now that we have popped out both sides and undone the side connectors, what you'll be able to see at the end of my pinky is we've got a connector leading into the bottom of the unit here with a red tab. So what you're going to want to do is get a screwdriver in between that red tab, pull it down, and then you'll be able to press the tab down. So what I'm going to do is I'm just going to get that disconnected now. If we grab the back of the unit and then kind of give it a little wiggle and lift up gently, it will come away from the center console. So what we're going to do now is we're just going to take it over to the bench, and then what we'll do is we'll start carrying out wiring checks on the connector that feeds the gear selector module. So we'll do that next. So on the screen in front of us, we have the wiring diagram for the gear selector module. Up here is the legend showing you what each of the designations mean in correspondence to the diagram, so have a look at that. If we zoom in on pin 1 here, we can see coming down, this is our power feed. So we're going to be checking that we have adequate power to the module. Now, if we start scrolling over to the right, what we have here is another power feed going to the unit, and this is our ignition feed. So when we're testing, we have to make sure the ignition is on. Now below this, pin 12, this is the earth, and over to the right on pin 5 and pin 6 we have our CAN high on 5 and CAN low on 6. So this is all the wiring that we need to check at the gear selector module, and that's what we're going to get into next. So now with the center console removed, we have access to our gear selector connector. Now, as we saw on the wiring diagram, we need feed at pin 1 and 2, and we need earth at pin 12. So what I've done is I've grabbed a test light. This one's from OTC, and what we're going to do is we're going to check that we've got power using the test light. So what I'm going to be doing is I'm going to be using the ground for the gear selector module to start with, and this is at pin 12, and this here is a purple and black wire. So what we're going to do is we're just going to back probe it there. Next, we're just going to grab another test probe, and we're going to go into the back of pin 1. Now, when I place my test lights into pin 1, we should see this bulb light up. And there you can see the bulb lights. So we do have power at pin 1. Next, what we need to check is we need to check pin 2. So move it over to pin 2 and touch the back of it. There we go. We can see that we have power. It's also worth mentioning that when we are doing these tests, it's important to have the ignition on when testing. If I just raise the screen, I can show you that I've got the ignition on here. So we have ignition on. So make sure we're carrying out the test with ignition on and that we do have power and ground. Now, our next step in testing the wiring leading to the gear selector module is we want to have a look at our CAN wires. Now, as we spoke about on the wiring diagram, the CAN wires are situated on pin 5 and pin 6, and what I'm going to be using is the picoscope 4225 alpha, I believe it is, in order to check our communication line leading there. Now, all I want to be seeing is the high-speed CAN that we're going from about 2.5 to 3.5 volts, and the low speed going from 1.5 to 2.5. I'll cross you over to the screen in a second and we'll be able to look at that. But all I've done is I've connected my red probe into the high-speed CAN, which is at pin 5. So as you're looking at the top of the connector, it is on the right, and the second one in from the right. And the low-speed CAN, which is on my black pin here, going to pin 6. And I'm just taking the earth off of the pin 12. So now what I'll do is I'll show you over to the computer screen and we'll see what we're reading on there. So now we have Picoscope 7 up and running. We can see that we do have a CAN signal present on the screen. Both my my voltage scale on the left hand side is at 5 volts.
What I'm going to do here is I'm just going to place a repeat trigger on the screen. That way we can just grab the readings that we're getting. Next, what I'm going to do is I'm just going to shorten the time base as well, just so we can get a bit more detail on the screen. And after I've just paused that, we're just going to quickly zoom in on the image. So minimize this box, and we're just going to move this screen recorder out the way as well. So looking at the voltages we have on the screen, center line is about 2.5 volts, and we're topping out at about 3.5. And on the bottom end, we're about 1.5. Now, if I drag my blue cursor, which is my CAN low, the lower voltage we're getting is about 1.4 volts. And to the high end of the recording, we're getting about 2.5 volts. So we're getting that 1.5 to 2.5 voltage range, which is good. And on the CAN high, our lower portion is 2.5 volts, and the higher at roughly 3.5 volts. So this is a good CAN waveform, and we are getting a good signal at the module.
So after doing all of that, we have tested both our powers and the ground supplied to the gear selector unit, and we have tested our CAN high and CAN low signals, which are showing perfectly fine. So what the next step is to do is we're going to take the gear selector unit over to the bench. We're going to remove it from the center console, and we're just going to open it up, and we're going to have a little look inside to see if we can find anything obvious. Now, what is very common with these units, and there are TPIs out for this, is that the units just fail internally on the board. Now, it's also known that there's a plastic rod that goes through the gear selector unit. This actually can break as well, and that will stop it from going up. But this customer had mentioned it was an intermittent issue. So I don't believe that to be the case. I believe that to be an electronic failure internal to the part. Now, the other variable with the testing we've conducted as well is that we haven't tested the CAN signal plugged into the unit to see if it's dropping the circuit down. If that was the case, however, it would be a defective unit at the end, and we didn't load test the wiring to the gear selector module. Now, I've already diagnosed this vehicle, and it does need the gear selector module, just to let you know. So I'm not going to be doing that, but it may be worth thinking about when you're doing your checks, and all you need to do there is you could just put a bulb in line with the circuit when you're testing, just to pull a bit of power on that circuit and make sure that nothing's bad on that end. But as long as you've got power and ground and you've got good CAN signal down there, it's going to be the gear selector unit. They are very common for failure. So next, what we're going to do is we're just going to go over to the bench. We're going to strip it down, and we're going to see if we can find anything wrong with the unit actually inside of it. So let's go and do that now. We've got just a protective cover on there just to make sure that we're not scratching the unit. What we'll do is if we flip it around, we can see the underside. Now, what we do have is we have a couple Torx 20s, and we have some 7mm bolts down here. And what we're going to do is we're going to take off this top fascia cover so that we can gain access to the screws on top, and then we can separate the unit away from the panel. So I'll just get that done now, and you can follow me along whilst I do it. So once the unit has started to come away after undoing 2 7mm at the top, 2 in the middle, and the 2 Torx 20s down this side, what we'll have to do is we'll have to get underneath and just unclip the wiring harness that runs through the metal channel, the plastic channels for the housing. Now, just like that, we can remove this out of the way and store in a safe place. And what we are now left with is the assembly. Now what we're going to do is we're going to separate the gear selector unit from this outer plastic covering. Now next step, what I'm going to do is I'm just going to take you through how we're going to take this apart. Then we can check out the internals and you can see for yourselves what goes into making and operating one of these. So at this point we already know the unit requires replacement. This is just so people can see what is on the inside. Now what we're going to do is we are going to remove this plastic top cover. Now I recommend you just get a small screwdriver and you go between the inner ring bezel, so this bit here, and the black plastic cap, and we're just going to work our way in and remove the cap. Now with this removed, we do have a centre Torx 20 screw. So what we'll do is we will just remove that. Get it out. So with that removed, we should be able to, if it wants to come away, as you can see, and the inner bit fell out, but the knob itself actually removes from the housing. So now with that centre knob removed, what we can do is we can turn it around onto its back, and we can proceed to remove the 4 Torx 20 bolts located on the outside. Now when you undo this, what you'll be able to do is you will be able to pull apart, and we get our first look at the circuit board as well as the internals, which we'll go into a little bit further in just a minute. Now if we just place that back over and remove these bottom 220s holding on this plastic cover, after removing the 2 screws, we do have some plastic tabs on the sides. So we just get our screwdriver and gently pry them over, and if you give it a light pull, we'll be able to remove the plastic cover as well. Now along with this, you can see we have 2 connectors. Now with that removed, what we'll be able to do is we'll be able to separate. So as we can see, this is the circuit board for the gear selector. Now this is what typically fails. If I was to remove these screws up here, what we would be able to see on the other side are things like the LEDs fitted to the board for the park reverse neutral drive switching. And this is the inside of the actual motor housing assembly as well. Now what we see here is this is the motor that drives the gearing up and down for the gear selector knob, which sits on top. So this is the motor that drives this up and down. And we also have a solenoid down the back here, and this is what controls the release of the park lock. So if you have an issue where yours isn't twisting, it's not enabling you to go out of park, this is why the solenoid down here isn't releasing this mechanism, so that you can't move. Now what I'll do is I will just separate the bottom of this unit from there, and we can see a little bit further as to what's in the bottom. This is just as simple as removing a few of the Torx 20 bolts on the bottom. what we can see is the motor that's left on the top of the unit and a drive belt. So this motor here actually drives this belt, and that in turn causes the arm, or the swirl joint if you were, that has the control knob on top of it, to go up and down inside the housing. Also, what we can see is our solenoid at the bottom, which is the one with both of the blue wires. Now, when this solenoid is activated, what that's going to do is pull this mechanism back off of the adapter so that this can twist and then change gear. So I hope that helps somebody out as to what's inside one of these gear selector units, and it gives you a better understanding as to what happens inside. So now what we're going to do is we're going to fit a new module, fit it back in the car, and then test its operation. Now, as we can see, the unit is reassembled, and now it's ready to be put back into the vehicle. What I should be able to do now is start the vehicle, and we should see it rise out of the center console. And as we can see there, it has risen. What I'll do is I'll show it from a different angle so you can see it. And there you have it. The new gear selector has been installed, and we've restored functionality to that unit and the vehicle. I hope if you're watching this video and you're experiencing similar issues, this video has helped you out as to how to diagnose the issue and fix the problem. Now, if you've enjoyed the video, please like, comment, and subscribe if you've got any questions. And make sure you stay alert as to new videos that we're going to be posting about what we do here at Stedmans Garage. So, many thanks for watching, and we'll see you on the next video.